Introduction and brief description of the works. The Keeyask Generating Station project is a collaborative effort between Manitoba Hydro and 4 Manitoba First Nations: the Fox Lake Cree Nation, Tatasqueyask Cree Nation, War Lake First Nation, and York Factory First Nation, working together to form the Keeyask Hydropower Limited Partnership. The Dragados Canada Leadcore Bird Joint Venture is providing this visual presentation to further demonstrate its capability to construct the project and deliver the results required by Manitoba Hydro. The joint venture will exceed Manitoba Hydro's expectations by completing the project in record time, accelerating the delivery date by an average of 4 months per unit. The Keeyask project consists of a hydroelectric generating station and related works, including 2 long riverbank dikes on the north and on the south, linked to the principal structures which span the Nelson River at Gull Rapids. The principal structures consist of a powerhouse complex constructed on the north side of the river, which will be connected to the North Dike. The spillway will be located on South Island. A central dam will connect the spillway and the powerhouse structures. The spillway will be connected to the South Dam by means of a short concrete transition structure. General construction process. The proposed general construction process is based on a schedule starting on June 27, 2014 and finishing on December 14, 2019. Construction activities will include the commencement of the Stage 1 diversion through construction of the quarry cofferdam, discontinuing flow within the northern channel of the river, as well as the construction of the North Channel rock groin and the causeways to G3 and N5. The construction of the North Channel Stage 1 cofferdam, construction of the Powerhouse Stage 1 cofferdam, the diversion of the entire flow of the Nelson River through the southern channel, and construction of the Stage 1 Island cofferdam. In order to take advantage of the 2015 summer window, the Central Dam Stage 1 cofferdam and rock groin will be built. At the beginning of the winter of 2015, excavation for the powerhouse will commence. The tail-raised summer-level cofferdam will also be built in order to finalize all the excavations. During the summer window of 2015, the main body of the central dam will be constructed, leaving the connections with the transition walls for a later stage. In 2015, construction of the Spillway Stage 1 cofferdam will take place. The Stage 1 diversion will permit undertaking of the excavation works and construction of the principal structures. Throughout the Stage 1 diversion, the river will be confined to flowing through the southern channel of the Nelson River. Construction of the North Dike will start in 2015. Excavation and construction of the earth structures, including the North Dam, parking lot, and North Access Road ramp, will see the partial completion of the northern section of the South Dam prior to the Stage 2 diversion, and the full completion of all the other scheduled construction activities inside the Spillway Stage 1 cofferdam, as well as the construction of the Stage 2 Island cofferdam, and finally, the breaching and removal of portions of the Spillway Stage 1 cofferdam. Beginning of the Stage 2 diversion by closing the river channel with the advancement of the South Dam Stage 2 upstream cofferdam from the Stage 1 Spillway cofferdam to the south side of the river. It will also close the South River channel and direct flow into the open sluiceways through the spillway for diversion purposes. The Stage 2 diversion will allow construction of the South Dam, the South Dike, and access to the South Shore. In the dry removal of the northern leg of the Powerhouse Stage 1 cofferdam will occur. The southern leg of the Stage 1 Powerhouse cofferdam will remain in place and form part of the transmission tower spur. Construction of the transmission tower spur completion of the scheduled construction activities inside the Stage 1 powerhouse cofferdam area, which are required to prepare the powerhouse for impoundment of the approach and tail race channels. Breaching and removal of the tail race summer level cofferdam. Impoundment of the forebay in stages linked to closure and construction of the spillway rollways. And finally, closure of the remaining sections of the spillway. Commissioning of the turbines will take place on the following dates. Turbine number 1 will be commissioned on August 16, 2019. Turbine number 2 will be commissioned on September 21, 2019. Turbine number 3 will be commissioned on October 23, 2019. Turbine number 4 will be commissioned on November 6, 2019. Turbine number 5 will be commissioned on January 8, 2020. Turbine number 6 will be commissioned on February 15, 2020. Turbine number 7 will be commissioned on May 2, 2020. Powerhouse construction process. The core methodology behind the construction of the powerhouse building will be to quickly erect the intake to its full elevation at 173.5 meters, as well as the lower block of the powerhouse to a level high enough to install the structural steel roofing on. This will be completed as early as possible within the time plan in order to enclose each unit, which will enable the work to continue under cover. A sheltered work area will facilitate work during the winter months and contribute to the schedule advancement. When the erection of any of the units occurs during the winter, hoarding will be used. Given the height and smaller size of these pours, only a winter hoarding consisting of insulated blankets will be used. The powerhouse blocks in Units 1, 3, and 5 will commence at the same time as the intake and the service bay units. To achieve this, there will be 2 shifts per day. Once the crews have completed Units 1, 3, and 5, they will be reassigned to the remaining units. Namely, the crew from Unit 1 will go to Unit 2 and then to Unit 7. The crew from Unit 3 will go to Unit 4. And the crew from Unit 5 will go to Unit 6. The superstructures, or roof, for each unit are built in cascade from Units 1 to 7, as Manitoba Hydro requires them, in order to allow the use of the bridge cranes from the service bay to each unit. The erection of the tail race will be delayed until the structural steel has been placed and the associated crane has been moved out of this position. Given that the roofs are placed late in the schedule, 4 crews will be used at certain points. No challenges related to the increased manpower need are expected at this point. Most of the crafts from the spillway and the intake will be completed by this time. Per unit construction plan. The joint venture will begin construction of IN and PH1. Work will stop on the powerhouse once the elevation of 141.1 meters is reached in the lower cone and 143.7 meters in the walls, where the steel structure is placed. Once IN and PH1 blocks are finished, the roof will be installed so that winter work may commence inside the covered area. The roof will allow the PH2 block to be completed indoors, including the concrete and mechanical elements. Once the roof structure is placed and the crane is moved away from the tail race position, the construction of the TR1 block will commence, and then the TR2 right after. As per the provided milestone plot, several milestones have been advanced in the schedule. The installation of the draft tube liners will occur 7 months earlier than planned in Manitoba Hydro's original schedule. The installation of the stay rings will occur 7.5 months earlier than originally planned. The plant ready for non-embedded turbine parts milestone will occur 4 months earlier than originally planned. The ready to start final commissioning milestones now occur between 3.5 and 5 months earlier than originally planned, and the in-service dates will occur approximately 4 months earlier than originally planned. joint venture experiences on similar projects. Owing to the extensive experience and success on similar projects, the Dragados Canada Leadcore Bird joint venture is uniquely qualified to undertake such a challenge. Carhuachi Hydroelectric Generating Station, Venezuela. La Breña Pumped Storage Project with Hydroelectric Power Plant, Spain. Aurora Mine Relocation Project. Albion Sands Sand Cell 2 project. Wasquatim Generating Station. Lower Churchill Project, Bulk Excavation and Early Works. Conclusion. The key to success for the Keeyask project will be the ability to work during the winter months, which will enable the original scheduled completion date to be advanced by around 4 months per unit. To achieve this goal, a detailed and comprehensive analysis of the schedule has been undertaken. The logic between construction of all project elements has been studied very carefully, optimizing the critical path. The methodology and equipment demands have been developed and refined in order to maximize productivity and avoid any loss of time, which drastically shortens the schedule and saves significant costs. Finally, it's important to mention that special attention has been paid to minimize the environmental impact during the execution of the works. The Dragados Canada Leadcore Bird joint venture is proud to assure Manitoba Hydro that its proven experience on similar projects and complete reliability in this field will ensure total success. The project will be constructed in record time and, most importantly, will enable Manitoba Hydro to produce and sell energy 4 months earlier than planned.